Hello, welcome to the UNCC Autocross Expo presentation. The main objective of the project was to design and model the front suspension components of a Cobra kit car. The car is expected to run in autocross events after it is completed and will experience high stresses, so this was accounted for in design. The secondary objective of the project was to finish modeling the chassis and rear suspension using a ferro arm. This will complete the 3D modeling of the Cobra as a rolling frame.
The overall requirements for this phase of the project were to design the suspension components consisting of the upper and lower control arms, as well as the uprights. The frame of the Cobra was previously modeled in SolidWorks, but will require some refinement before moving forward. The 3D modeled parts will then need to be assembled and optimized using both Lotus and ANSYS. Following the design and optimization of all components, each part will either need to be acquired from an outside source or manufactured, then installed on the chassis. The suspension components have already been 3D modeled, with the system's geometry being determined. A supply list has been created and team members have received ferro arm training.
Okay, for the design of this suspension, we implemented a double A arm design using the parameters that we were given. We wanted to model the design with the maximum amount of adjustability possible. So we utilized slugs as well as adjustable lower and upper control arms. And then we will be using Lotus Shark and ANSYS software to do further optimization and design.
Okay. The model displayed is a modular model of the front suspension assembly. The isometric view shown includes the tie rods, uprights, and upper and lower control arms. Our design maximizes the amount of adjustability achievable for the car so that it can be further optimized once it's been tracked. In the next view, it can be seen that we can interchange the stock and design components if different geometry is desired. This slide shows the current suspension geometry as it is applied to the current framework. This will be modified through our analysis in Lotus, Shark, and ANSYS.
The design process the team went through is not only applicable to the car it is being installed on, but also any other car where a performance suspension is needed. We have shown consideration for existing parts and designed our model around easily obtainable aftermarket parts. In addition to this, our components were also designed with serviceability in mind. We realize at the track that it is imperative the suspension be easily adjustable. With that in mind, the suspension was built around a slug adjustment system in order to easily and accurately adjust caster camber, bump steer Ackerman, and even track width.
The suspension design will undergo FEA testing and optimization, with any other final changes being made. The front portion of the chassis will be scanned via the ferro arm and redesigned to fit the new suspension geometry. We will finish the project with the manufacturing, assembly, and installation of the suspension system.